Hi there and welcome to the R for Data Science exercise walkthrough series. My name is Thomas and today we're continuing our journey in chapter 5 of the R for Data Science book, Data Transformation. More specifically in chapter 5.3, Arrange Rows with a Range. So this is all about sorting your data set just the way that you want it. Let's start off with the very first exercise. How could you use a range to sort all missing values to the start? And then we get a hint to use the is.na function. So if I just scroll up a little bit, there's an example of what happens when you sort a data frame that contains missing values, which are coded as NA in R. So you can see if you use arrange to sort it in ascending order, we get 2 first, 5 seconds, and NA are always at the end. And interestingly enough, even if we sort by descending order, 5 is first, then second, and NA still last. So what we can learn from this is basically that NAs will always get in the last position when you sort. There is, however, a trick to make the NA values come up at the very top when sorting, and this involves this is.na function. So let's jump straight into RStudio. Let me quickly load the dplyr package, as well as the NYC flights 13 package. Then I'm going to open the documentation for the dataset flights, which will come in very handy. And then let me just quickly copy that little snippet from the book here to create this little data frame with this one column, which contains NA values. All right, so just to reiterate, if I use arrange df by x, we see NA is at the bottom. And even if we sort in descending order, it's still at the bottom. So the correct way to get the NAs on top is to use the is.na function. And so this may look a bit funny to you, but what we're saying here is we do not want to sort by the existing column X that's already in data frame, but we want to sort by the transformation of X that is the result of applying the is.na function. So let me quickly do is.na on df $x, and you can see we get false, false, and then for the last value, which indeed is an A, we get a true. Now, how can you sort these false and true values? So what happens if you try to sort them is that R will automatically convert them to numbers. And we can see how this will look like by using the s.numeric function. And as you can see, false gets converted to zeros and true gets converted to 1. Now, if we want to get the NAs up top, what we then have to do is we have to sort by descending is.na of the respective column. So let's try that out. Arrange df descending of is.na of x. And as you can see, we indeed get NA up at the very top, and then we just see the numbers sorted in the right order. So that's how you can get your NAs up top. Descending is.na and then your column of interest. All right, then let's continue with the second exercise. We're asked to sort the flights dataset to find the most delayed flights, as well as the flights that left earliest. Okay, so if we look here on the left into the documentation of the flights dataset, we see that we have departure delay as well as arrival delay. And now for this case, I will sort by arrival delay. Let me quickly do that. So arrange flights. And now because we want the most delayed flights, we want to sort by descending arrival delay. Now there is kind of a problem that we don't really see if we did the right thing, because the arrival delay column is not displayed here on the screen. So let me quickly bring that at the very front of our data set, and I will do that by using the select function from dplyr. So select flights, then the column of interest, which is array delay, And then there is a nice little trick to get the rest of the columns, which is using the everything function. So what this will do is it will put a arrival delay as the very first column and then everything else after it. And now if I hit the up key to get my previous command and sort once again, we can see arrival delay is displayed as the very first column, and indeed it seems to be sorted just as we wanted. The biggest value is in the first row and then subsequently gets smaller and smaller. Excellent. So let me just quickly go back. The second part was to find the flights that left earliest. Okay, so we have a departure time column in the data set, and we learned that it's formatted in this way. So it's either HHMM or HMM, which basically means that the smaller the number is, the earlier in the morning the flight departed. So I will use the same trick as I did just to put this column at the very front of the data set. So departure time. And then let's see, we want to arrange flights, this time not by descending, but actually by ascending. So we just use departure time. And we see we get the ones as the first entries. So in this coding, H and M, this would correspond to basically this time. Yep, exactly. So seems to be right. Excellent. Next up, we're asked to sort flights to find the fastest or highest speed flights. Now I did look at the data set before recording this, and there's not really a speed column. So what I will choose as kind of a proxy, and this might not be really a good one, but I will just use the airtime, and I will not actually compute the speed by doing some kind of calculations, because mutate, actually the function that you use to create new columns, has not yet been introduced in the book. So instead I will arrange flights by descending air time. And again, we have the problem that we don't really see if we did the right thing. So let me quickly move the airtime column to the front and sort once again. And we can see that the longest airtime seems to be almost 700 minutes. Okay, time for the final exercise. Which flights traveled the farthest and which traveled the shortest? So looking at the help page, we can see we have a distance column, which is the distance between the two airports in miles. So that's how far the planes traveled. So first off, let's move this column to the front, again using the little select trick. Flights, distance as first column, and everything else after it. And then we arrange again the flights data set. We will start with those that travel the farthest. So we want to sort by descending distance. And we can see that the farthest is around 5,000 miles, so quite a bit. And in contrast to that, if we remove the descending function and sort in ascending order, we can see that the shortest flight was just 17 miles. So you don't really need a plane for that, but apparently it did fly. All right, that's it for this episode. Thank you very much for listening. If you enjoyed this video, make sure to subscribe to the channel and leave a like down below. I'm also happy to receive any kind of comments you may have. If you have any questions, I'll definitely get back to you. See you on the next episode. Cheers.